Welcome to qnawire.
Okay, in this question, we have a few bars that are connected by four link points, O, A, B, and C. We're told that the bar OA is rotating about point O with an angular velocity omega 0 of 10 radians per second. We have the lengths for each of these bars, and we're given some angles to start with. And what we'd like to do is find the angular velocities of links AB and BC. So first, we can find the velocities of some of these points. So the velocity of point A should be pretty simple to find. That'll just be the length of OA times omega of that link OA, which is just omega 0 here. Omega, or OA, is 0.08, omega 0 is 10, so this should be 0.8 meters per second then. Next, we can draw a velocity diagram, which I'll switch colors for here, for comparing velocities A and B, which will be the two important moving points here. So, well, velocity A is moving up and to the left. Velocity of B will be moving directly left. And then we'll have the velocity of B with respect to A. Velocity of B with respect to A. Velocity of A. Velocity of B. And we'll have all of the angles. If we look at this carefully, we end up with two 75-degree angles and one 30-degree angle. Just based on the geometry of the situation. And we know that VB has to be moving directly to the left because its bar rotates about point C at the bottom here. Point A is moving up and to the left, and that's where we get the 30-degree angle from. So we can use the law of sines then to help find VB. We know that VB over the sine of 75 degrees should equal VA over the sine of its opposite angle, which is 75 degrees, which then tells us that VA equals VB. So we know what both VA and VB are now. We can then use this to figure out what VB with respect to A is. So VB with respect to A over the sine of 30 degrees equals VA over the sine of 75 degrees. When we solve for VB with respect to A, this gives us VB with respect to A is 0.414 meters per second. We can then use this to find the omegas we need to find. So first, we'll find omega BC. So that's the omega of this rod on the left here. So omega BC would equal the velocity of point B divided by the length of that rod, BC. The velocity of B is 0.8 meters per second, and the velocity or the length of BC is 0.2 meters. So this gives us then 4 radians per second. We can do something very similar for omega AB. Omega AB will just be the velocity of B with respect to A divided by the length of that rod, AB. velocity of B given, or with respect to A, is 0.414. Length of AB is 0.24. So when we do that division, we get 1.73 radians per second, roughly. And then we need to make sure we say what direction each of these are moving in. Omega 0 is a counterclockwise direction. AB is moving in a counterclockwise direction as well. Since A is moving up some, B is just moving to the left. And BC is also moving in a counterclockwise direction. So everything here is counterclockwise.